In this video, we will see some ways to use the signal type event. Signal events are used to send or receive signals within or outside the process. For this reason, they're useful for both communication between parts of the same process and between processes linked by a hierarchical relationship. This implies that it's possible to signal the occurrence of an event that can be detected in any part of a process, subprocess, or even parent process. The signal behavior varies depending on whether they're start events, intermediate events, or end events. In turn, these events can trigger a signal, throwing, or receive a signal, catching. The notation used changes accordingly. For example, intermediate events have a double border, while start and end events have a simple border. When they're triggering events, the triangle is dark. And when a signal is captured, the triangle is clear. A start signal event allows a process to start when a signal is received from another part of the process, or processes hierarchically related to the process where it's defined. For this reason, they're always of catch type. When a process flow ends, a signal event of end type allows sending a signal to another part of the process or processes hierarchically related. They are always of throw type. A signal event of intermediate type can be of throw or catch type. Depending on the value of the isThrow property, true or false respectively, and it can be placed in any part of the process, usually between activities. Let's see some of these symbols in action. The travel agency has requested us to model the process used to publish travel packages for their clients. Each package includes several ticket and hotel reservations, and one package can be published only if there are tickets and hotels available. This implies that the process must allow securing a certain number of tickets and rooms so as to be able to promote packages of a certain tourist attraction. In addition, the process must be efficient. This is to say, the inquiries to airlines and hotels must start at the same time, and if the minimum number of tickets is not obtained, the search for hotel rooms must be canceled. The process must guarantee that packages are only published when both tickets and accommodations are booked. To implement this process in Genexus, we open the Genexus modeler. We create an object of business process diagram type and call it develop travel packages. First, we drag a none start event symbol. Next, we insert an interactive task and call it pre-select attractions, and then we connect it from the none start event. This task encompasses the activity of examining which attractions are more suitable to be included in a package. Next, we must start one process to search for tickets and another process to search for hotels. To do so, we drag the symbol of an embedded subprocess, we call it find available tickets, and we join it from the task defined before. Then we add another embedded subprocess called find available accommodations, and then we also join it from the task pre-select attractions. In order to complete the process of developing travel packages, we must make sure that both subprocesses have been successfully submitted. This may be done by defining a relevant data item of Boolean type set in each process, depending on whether this process has been successfully completed. Next, we should use an inclusive gateway to synchronize the paths coming from each subprocess, so that the package development process only ends if both subprocesses have been successfully completed. Even though this solution is possible, it implies defining and setting relevant data. We can obtain a similar result by using signals with no need for this relevant data. Instead of the inclusive gateway, we insert an end event of signal type and connect it to the output of the subprocess that looks for available tickets. We call the signal tickets available, and we see that an end event of signal type is already of throw type, because the triangle is dark. In a signal end event, we can't change the value of the isThrow property because it isn't available and its value is always true. In the same way, we insert a signal end event to the output of the subprocess that looks for hotels, and we call it accommodations available. Now we must catch these signals to continue with the process to develop travel packages. That is to say, to publish them and finally end the process. To do so, we insert a parallel gateway to which we connect from the preselect attractions task. This will allow us to fork the flow into two paths. Unlike the exclusive gateway that is used when the path to be followed by the process flow depends on the evaluation of a true or false condition, a parallel gateway allows us to split the flow in two or more paths without evaluating any conditions. For this reason, it's also possible to model the same behavior without using a parallel gateway, simply by joining two connectors. However, the use of a parallel gateway can help clarify the diagram in certain circumstances. Joining several paths to follow only one of them is called synchronization. In this context, exclusive gateways can also be used for synchronization, even though they're rarely necessary for modeling because it can generally be modeled without them while obtaining the same behavior. This modeling method is rather risky, because since there's no synchronization, the task after joining the paths could be executed several times, once for each path that was joined, as the flow sequences of each path arrive. To avoid this, we must use a parallel gateway to join paths. A parallel gateway waits for all the incoming flow sequences and does not continue until all of them have arrived. However, in some cases, an exclusive gateway is required for synchronization. In this example, if the exclusive gateway was not used to synchronize the result of a previous gateway, the parallel gateway would have 4 input sequence connectors. However, only 3 of the 4 flow sequences could pass at a time because of the exclusive gateway at the forking. Therefore, the process would get stuck at that parallel gateway. Going back to our model, we add an intermediate event of signal type for each path, and then connect them from the parallel gateway. We call the signal on the left path tickets available, and leave the isThrow property set to false. Note that this signal is of catch type. It'll catch the throw signal with the same name that is triggered when the ticket search process ends. We then do the same thing with the other signal. We call it accommodations available, and set its throw property to false. In turn, this one will catch the signal sent when the process to search for accommodations ends. Next, we insert another parallel gateway to join both paths. This will prevent the process from continuing unless both signals are received. Lastly, we insert a task called publish packages. And then we connect it from the parallel gateway and add a none end event to end the process, to which we add the description, packages successfully developed. In this way, the implementation meets the requirement of not completing a process unless the necessary tickets and accommodations are obtained. However, this process is not efficient. Remember that the travel agency has requested that the process to search for accommodations must not start if the tickets have not been previously obtained. To do this, we also use signals. We double-click on the process Find Available Tickets to define it. A blank window opens to add the symbols representing the process to obtain the tickets. First, we insert a none start event and a task called contact airlines. Since this task will be run several times, one for each airline contacted, we open its loop type property and we set it to multi-instance. To examine the information obtained once all the airlines have been contacted, we insert a script task called check availability, and we connect it from the task contact airlines. And now we drag an exclusive gateway. If there are tickets available, we end the process with an end event, which is the default path. If there are not enough tickets available to create a travel package, we end the process with a terminate end event that not only ends the subprocess, but also ends the main package design process. Next, we'll define the accommodation search process to check if we can offer a package for the pre-selected attraction. So we double-click on the subprocess Find Available Accommodations. We drag a none start event. Next, we insert the symbol of an intermediate event of signal type. We call it tickets available, like the signal end event at the end of the ticket search process for the package. We open its properties and check that the isThrow property is set to false, because we want this event to catch the signal sent when the ticket search process is completed. In this way, the process to search for accommodations will continue only if there are tickets available for the package. To continue defining the process, we insert an interactive task called Contact Hotels. We set its loop type property to multi-instance, because this task should be run several times, once for each hotel contacted. Next, just like in the ticket search process, we insert a batch task, and we call it Check Accommodations Availability. This will check if there are enough hotel rooms available to offer the package we're designing. Finally, we insert an exclusive gateway. And if there are hotel rooms available, which is the expected result, we end the process with a none end event with the tag places available. Otherwise, we insert a terminate end event with the tag no places available. We close the subprocess window, we return to the main process, and save. In this way, we've defined a process that meets the objective of efficiently designing a travel package, just like the travel agency had requested. The signals have provided us with a communication method between the various parts of the main process and between the main process and its subprocesses to achieve the objectives we had set out. To learn more about this topic, visit the link displayed on screen.